Okay friends, welcome to MRP classes. We will continue the thermodynamics here. Today we will discuss the details of enthalpy of reactions. This is another hot area for the questions. I will give you the tips and tricks and some sample previous questions. Rest is your side. Develop it, prepare it and make it advanced. Obviously you can solve questions from these topics. Okay, today my targets are standard enthalpy of formation, standard enthalpy of combustion and standard enthalpy of reactions and their connections. Okay, what is the standard enthalpy of formation? What is this? It is the heat change or enthalpy change, heat change or enthalpy change when 1 mole of, very important, when 1 mole of any substance is formed. Therefore, this value, whatever the value, that's for 1 mole. That's for 1 mole. Now, your substance will have different states: liquid state, solid state and gaseous state. What is the standard state? Delta H0 formation of an element, standard state. Standard state is the stable state at 298 Kelvin. At 298 Kelvin. Suppose you have water. What is the standard state of water? Liquid. This is a standard state. Because at 298 Kelvin, water is in the liquid form. But for carbon dioxide, standard state is gaseous state. For carbon, standard state is, very careful, graphite, not diamond. If a substance is can exist different form in the solid state, most stable state is the standard state. Therefore, carbon has graphite form and diamond form, fullerene forms, different forms, but the standard state is graphite. And there is one more point. For an element chemically, delta H0 formation of elements is equal to 0. That is, delta H0 formation of chlorine, gaseous state, oxygen, gaseous state, carbon, graphite, hydrogen, gaseous state, fluorine, gaseous state, bromine, liquid state, all are, any elements in the standard state is equal to 0. But if a delta H0 formation of a substance Suppose water or carbon dioxide minus 393 Kelvin, suppose kilojoule per mole. What is this value? This is delta H0 formation of carbon dioxide for 1 mole. Now, suppose you write delta H0 formation of C6H6 is equal to minus a kilojoule per mole. What is the meaning of this information? What is the meaning of this information? One information is when 1 mole benzene formed, this much heat is liberated. This much heat liberated. Now, second is, this is the form C6H6. Delta H0 formation is equal to minus A, meaning that benzene is formed from 6C graphite, 6 mole of graphite and 3 mole of H2 gas. This is a standard state. This is a standard state. Its value is 0. Its value is 0. And this is entire reaction. In this reaction, delta H0 reaction is equal to delta H0 formation of benzene, because in this reaction only one product is obtained, that is benzene. Therefore, this reaction is equal to delta H0 formation of benzene, which is equal to, the product is this, its value minus A minus because delta H0 formation of benzene, this value, this is already given. What is the delta H0 formation of carbon? It's a pure element, therefore 0 into 6, that is 0. What is delta H0 formation of hydrogen? It is an element. For an element, delta H0 formation is always 0, therefore 0 into 3. Therefore, this is minus A. Therefore, this data gives you, this value is delta H0 of reaction. This is equal to delta H0 reaction. This is delta H0 formation of benzene, that can be calculated like this. This value becomes delta H0 formation of benzene because these are zeros, arbitrarily fixed as zeros. Okay? Now, delta H0 formation can be negative as well as positive. It need not be always negative. Delta H0 formation can be negative or positive. Negative means exothermic, this is endothermic. More negative, more the stability of product. More the stability of product. Product will be more stable if it is more negative. Why? Because that product is formed by releasing lot of energies. When energy lost, stability will increase. Therefore, you keep in that mind. Fine? Yes. Now, we can go to another relation, that is enthalpy of reaction. What is enthalpy of reaction? It's a general term. It is the heat change associated with any reaction represented by a balanced equation. Any reaction, heat change associated with any reaction represented by a balanced equation. Okay. Suppose you have a reaction C6H6 plus O2 gives 6 CO2 plus 3, okay, I'm sorry, 3H2O (7 by 2). Or you write like this: 2C6H6 plus 7O2 gives 12 CO2 plus 6H2O. Enthalpy of reaction means heat change during this reaction. Here when 1 mole, here 2 mole. Here also an enthalpy of reaction. This is suppose 1, 2, this is 1. Both are different because it is here number of moles are changing. Now, listen here, I will tell you one important point. Delta H0 combustion, heat of combustion, it is a heat change associated with, now I am going to define this. What is this? It is the heat change associated with the combustion of 1 mole of any substance with the required moles of oxygen. Required moles of oxygen. Yes. Only the combusting substance should be 1 mole. Oxygen need not be 1 mole. Now I will tell you, here it is 1 mole, 7 by 2 mole oxygen. Therefore, this enthalpy of reaction is equal to enthalpy of combustion. All enthalpy of combustions are negative. All enthalpy of combustion is negative, but not enthalpy of reaction cannot be always negative. It can be positive also. But here also you have an enthalpy of reaction that is not equal to enthalpy of combustion. I can say this is enthalpy of combustion into 2 because here are 2. Okay? Yes. Similarly, I have said to you in the just before, enthalpy of formation can also be enthalpy of reaction. Now, enthalpy of here some case enthalpy of reaction is equal to enthalpy of combustion is equal to is relation between enthalpy of combustion and enthalpy of reaction with enthalpy of formation. Sum of enthalpy of formation of products minus sum of enthalpy of formation of reactants. This is their relation. Relation between enthalpy of formation, enthalpy of combustion and enthalpy of reaction like this. This will be equal only this case because here reactant is, this is a combustion and reactant is 1 mole. Fine? You don't apply this here. Now what is that? What is the products? 3 into delta H0 formation of water plus 6 into delta H0 formation of carbon dioxide minus 1 into delta H0 formation of C6H6 plus 0. Why 0? Because for an element enthalpy of formation is equal to 0. Okay? When you come here, you have an enthalpy of reaction, you will get same relation also here. Okay. Therefore, you have to keep these things always in your mind. Very simple. Now we can solve a previous question. This is a question. Delta H0 formation values in kilojoule per mole for carbon dioxide, gas, H2O liquid are 393.5 kilojoule mole raised to minus 1 and minus 285.84 kilojoule mole raised to minus 1 respectively, and heat of combustion of C7H6O2 is minus 3229.8 kilojoule. Calculate delta H0 formation and delta U0 formation of C7H6O2. This is the question. Okay. Heat of combustion or enthalpy of combustion of this is given. What is enthalpy of combustion? C7H6O2 1 mole. Take the oxygen. When you combust, you will get carbon dioxide and water. Carbon dioxide and water. 7 carbon dioxide and 3 oxygen. Seven by 2. Get here. Yes, 7 by 2. Now, heat of combustion or enthalpy of combustion is given. Delta H0 combustion or enthalpy of reaction is equal to. In terms of you have the enthalpy of formation. That is, what is for carbon dioxide? This. 7 into, for carbon dioxide, 393.5 plus 3 into, here a minus sign, minus sign, into, here a minus sign, 285.84 minus, reactant side, this is 0, because it's an element, gas. Okay, this is liquid, this is gas, this is liquid. You don't know what is this delta H0 formation of C7H6O2. This is you want to calculate. This value is therefore minus 3229.8. Here and minus is equal to minus 3612 plus delta H0 formation, minus delta H0 formation of C7H6O2. Here a minus. Therefore, minus delta H0 formation of C7H6O2 is equal to minus 3612 minus 322 and 0.8. Okay. So almost here a minus sign. Final answer is minus 382 kilojoule per mole. Delta H0. You will get a positive value here. When you transfer the minus there, you will get a negative value. This is a delta H0 formation of C7H6O2. Now Now the next, what is delta U0 formation? We have a relation delta H0 is equal to delta U0 plus delta NGRT. In the case of formation, you like this. Now, what is delta H0 formation of this? This is formed, 1 mole of this formed from its element. To form 1 mole, you need carbon, hydrogen and oxygen. How many oxygen? 2 oxygen. How many hydrogen? 3. 6 hydrogen. Therefore 3H2. How many carbon? 7 carbon. Carbon should be in the elemental form, stable graphite. It's gas, it's liquid. Now you please calculate delta Ng. Delta Ng is your product 0 because it's not gas, minus 1 mole gas, 3 mole gas, 4. This is graphite solid. Therefore, delta U0 formation is equal to your value minus 382 H0. Here you have a minus 4 RT. That is plus 4 into 8.314 into 10 raised to minus 3 because it's a kilojoule. Make it in kilojoule into 298. Okay, this is the answer. Fine. Understand these topics. It will help you to solve the question. I have discussed only one previous question. You can solve other similar questions from the question paper. You will get it. Any doubts? Let us discuss in the video. You comment it. You subscribe this. Thank you. Thank you for watching.